All right, good morning. So this question is from the chapter of derivatives. And as you can see, the question is very long and can give you jitters to start with. Now, when I notice such a question, I see the sign that all these are getting multiplied, and in the denominator also, all the polynomials are getting multiplied. So the very first thought that comes to my mind is that if so many you know polynomials are getting multiplied and there is a power also, the best way forward is to use the properties of log. Now I know log of a into b into c into d divided by e into f into g into h. If I were to do this, I will write it as log of a into b into c into d minus log of e into f into g into h, and then of course I will open this. This will become log of a plus log of b plus log of c plus log of d minus log of e minus log of f minus log of g minus log of h. So a very long expression like this, you know, becomes an addition, and the the way you solve this is, if you notice this question, I apply the same approach to this, okay, and see what happens, because I'm very sure a lot of things will get cancelled because of this, right? So log of y is equal to log of this whole, and of course you have a numerator. It starts from under root of 1 plus 2x, the other one, and ends at this, right? So let's say we open this, okay? So log of y is equal to, so I'm using the same principle as this, and I'm writing this as log of 1 plus 2x. The power is half, which I will bring here, and then it is 1 by 4 log of 1 plus 4x plus 1 by 6 log of 1 plus 6x, and this will continue till 1 by 100 log of 1 plus 100x, right? Now there is a denominator also, which is primarily what these are odd numbers, okay? So if you notice, these are odd numbers. So minus 1 by 3 log of 1 plus 3x minus log, and then 1 by 5 log of 1 plus 5x minus 1 by 7 log of 1 plus 7x, okay, dash dash dash, minus 1 upon 101 log of 1 plus 101x. So if I take derivative of this, this is 1 by y is equal to half into 1 plus 2x, and then there is, all right. So if we continue to find the derivative of this, now we can write this whole sequence the way I'm writing this. So this will become 1. So we have taken the derivative of this, okay, and let's take the derivative of this, because it is 1 by 3 though negative. So I'm going to write 1 by 2 and then a negative 1, okay? So minus 1 by 3, and this is 3 upon 1 plus 3x plus 1 by 4 1 plus 4x and 4, then again minus 5 upon 5 1 plus 5x, so on and so forth, and this will continue till 100, right? So this is 100 divided by 100 1 plus 5x minus 101 and 1 plus 101x. Sorry for that, I think we just moved a bit, and let me just create some space here, and this is 101 and 1 plus 101x, okay? Now if you see, all these will get cancelled, and this is what we are reduced to: 1 plus 2x minus 3 upon 1 plus 3x 1 plus, so 4 is also gone, 1 plus I mean, at least some pattern is emerging out of this, right? And so this is also 1 upon 1 plus 5x. So you can see the even is this and odd is this, right? So 1 plus 6x minus 1 upon 1 plus 7x, and then you have 1 upon 101. So this is odd, 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 and last one negative is also odd. Now if you see, if I combine these, by the way, okay, if I put x is equal to 0, please see the question. You have to find the derivative at x is equal to 0. So a relatively simple question, right? X equal to 0, if you put, you get 1 by 1 minus 3 plus 1, this is 4. So this is gone. So 1 minus 3 is gone, right? So this is also 1. So 1 minus 1 plus 1, this is minus 1, okay, plus 1 minus 1, right? So all this 4x, 5x at x equal to 0, these are turning out to be zeros, right? So 1 plus into x plus 1, right? And the 101 also gets cancelled. So you see that 1 minus 1 plus 1. So the even ones are getting cancelled with the odd ones, you know, in pairs. So if you reach to the last one, which is 100, it will get cancelled with the 100 first, right? So what you're getting practically is the answer is coming out to be 0. And let's see what is that needs to be proved, right? We have to find y dash at x equal to 0. So you can see dy by dx into 1 by y is equal to 0. So dy by dx is equal to y into 0, and dy by dx, which is y dash, is equal to 0, right? This was a fairly straightforward question because the only thing was the properties of logs being used, right? So I took the log, it became very simple for me to take the values. Now if you consider the another situation, which is you have to find the derivative at x is equal to 1, which is where, you know, if you see the whole derivative and I put the value in this particular expression which I got in the last, I will be left with something like this, okay? That dy by dx into 1 by y is equal to 1 by 2 minus 1 by 3 plus 1 by 4 minus 1 by 5 plus 1 by 6 minus 1 by 7, etc., till plus 100 minus 101, right? And if you notice, you know, although this is not till infinity, this is pretty much finite. Sometimes you have to apply rules of log of 1 plus x expansion also in some questions, okay? And then you can also know what is the expansion of log of 1 plus 1 minus x, for example, right? So log of 1 plus x can be written as x minus x square by 2 plus x cube by 3 minus x4 by 4. So these are expansions, and these also need to be understood for some of the questions, okay? So questions series like this, 1 by 2, 1 by 3, 1 by 5, if you encounter them, you will see that the expansions get utilized. So you should be very clear in your mind, you know, that logarithmic properties are clear in your mind and how to use them effectively in certain situations. I hope you enjoyed this question. I think the point was that logs can make your derivative pretty simple if you have knowledge of logs, and then you put the value where the derivative is to be found, and you can easily find the answer. So thank you very much for your time. I hope you like this. Do watch my videos on this channel. There are 2000 videos, more than 2000 on different topics, and I'll come out with more videos on physics and chemistry and maths. Thank you.